Another method of apportionment is the Huntington-Hill method. The method is similar to the Webster method, but attempts to minimize the percent differences of how many people each representative will represent. There are two ways for implementing this method. First method is each state is first given one representative, and then additional representatives are assigned one at a time to the state currently having the highest Huntington-Hill number. This method will be discussed in another video on how to find the Huntington-Hill number and how to use the method. Second, it uses a modified divisor and a special rounding procedure that involves the geometric mean of two consecutive integers. To apply the Huntington-Hill method of apportionment, we first calculate the standard divisor, that is by dividing the total population with the total representative to be apportioned. And then calculate the quota rounded to the nearest whole number, or that is the lower quota, which we will call n. Initially, each subgroup receives a number of seats equal to its lower quota. And then we compute the geometric mean, that is the square root of n times n plus 1 of the lower quota and one value higher. So if the quota is larger than the geometric mean, we round up the quota. If the quota is smaller than the geometric mean, we round down the quota. So if the sum of the resulting whole numbers is equal to the number of seats to be apportioned, then the apportionment process is complete. But if the sum of the resulting whole numbers is less than the total number of seats to be apportioned, we reduce the divisor and recalculate the quota and allocation. But if the sum of the resulting whole numbers is larger than the total number of seats to be apportioned, we increase the divisor and recalculate the quota and allocation. Then we continue doing this step until we get the total number that is equal to the number of seats to be apportioned. For example, Barangay Dalogan is composed of 4 clusters. There are 350 sacks of rice to be apportioned among the 4 clusters, according to their respective clusters' total population. The population in each cluster is given in the following table. So again, we compute the standard divisor, that is 5,250 divided by 350 sacks to be apportioned. That will give us 15. So 1,250 divided by 15, this will give us 83.33. 985 divided by 15 is equal to 65.67. 1,420 divided by 15 is equal to 94.67, and 1,595 divided by 15, that will give us 106.33. So the lower quota, we round this to the nearest whole number, or we round down. So we have 83, 65, 94, and 106. Simply we drop the decimal numbers. Next step is we compute the geometric mean for each subgroup. So we have square root of 83 times 83 plus 1, that is 84, and that is equal to 83.49. Next, we have the square root of 65 times 66, and that will give us 65.49. We have square root of 94 times 95, that is equal to 94.49. We have square root of 106 times 107, that will give us 106.49. So we compare the quota and the geometric mean for each subgroup. So if the quota is larger than the geometric mean, we round up. So that will give us the initial allocation. But if the quota is less than the geometric mean, then we round down the quota. So for East, 83.33 versus 83.49, since geometric mean is greater than the quota, then we round down. So that is 83. 65.67 versus 65.49, since the quota is larger than the geometric mean, we round up. So that will give us 66. So next, 94.67 versus 94.49, since the quota is greater than the geometric mean, this means we round up. So that is 95. 106.33 versus 106.49, since the geometric mean is greater than the quota, then we round down. So that will give us 106. And if we total this up, 83 plus 66 plus 95 plus 106 will give us 350. And this is the total number of socks to be apportioned. So the apportionment process is complete. So what if the total of the initial allocation is not equal to 350? So that will give us less than or greater than 350. Then we recalculate the quota using our modified standard divisor. But for this, since we already got the number of socks to be apportioned, then this is complete.